In this video, I'm going to clarify a derivation that was done in lecture 29 at around time 24 minutes and 22 seconds. This was a derivation of L sub z, which represents the component of the insulation vector along the zenith axis. Here's a diagram that was given in the lecture that expresses the insulation vector in the local centric coordinate system on the left and in the Earth-centric coordinate system on the right. Before moving on with this video, I'm assuming that you understand the equations up to this point. The equation at the bottom represents the zenith component of the insulation vector, L sub z, expressed in terms of the Earth-centric coordinate system vector components, L sub m and L sub p. Now, some people in the comments were confused by how this expression was derived. So my hope is to provide some clarification about this topic. The first thing I want to do is rewrite the insulation vector equation with some additional mathematical notation. Here I've just added an arrow on top of the insulation vector, L, to denote it as a vector. I've also explicitly written out the unit vectors s hat, e hat, and z hat that form an orthogonal basis for the local centric coordinate system. S hat is the unit vector that points along the south axis direction, E hat points along the east axis direction, and Z hat points along the zenith axis direction. Here, L sub S, L sub B, and L sub Z are scalars defined in the same way as above. Similarly, I've also rewritten the insulation vector in the Earth-centric coordinate system with the additional notation. Let me remind you that we are trying to solve for L sub z in terms of the Earth-centric coordinate system vector components, L sub m, L sub e, and L sub p, as well as the rotation angle phi. To accomplish this, we first have to do a coordinate transformation. That is, we start with the insulation vector expressed in the Earth-centric coordinate system with unit vectors m hat, p hat, and lowercase e hat as our basis. Then we need to express these unit vectors in terms of the local centric coordinate system with the unit vectors z hat, s hat, and capital E hat. Here on the left, I've redrawn both of the coordinate systems defined in the same way as in the lecture. Using trigonometry, we can express the unit vector m hat as z hat times cosine phi plus s hat times sine phi. The same can be done to obtain expressions for p hat and lowercase e hat. The final step is then to substitute these expressions into the insulation vector equation. After doing that, this is what we get. And after rearranging the terms, we obtain this final expression. By setting the final expression equal to the top expression, we can finally solve for L sub z as L sub m times cosine phi plus L sub p times sine phi. So that's all for this video, and I hope that helps.